Alright, this is A6. For numbers 53 to 56, they want you to find all values of x such that f of x equals 0. So we're going to set f of x equal to 0, and then after we do that, we solve for x. So we have replaced the f of x with 0, and then we have 0 equals 15 minus 3x. We solve for x. We can subtract 15 from both sides, and then divide by negative 3. So we end up with x equals negative 15 divided by negative 3 is 5. For 54, same thing. We're going to set f of x equal to 0. So this is 0, and then we're going to solve for x. So we subtract 1 from both sides, and then after you do that, you divide both sides by 5, because you want to isolate the x. So we have x equals negative 1/5. So 55, same thing. F of x is 0, so we replace f of x with 0, and then solve for x. So the first thing I'm going to do is multiply both sides by 5. And you know, 0 times anything is 0, so the 5's on the right reduce to 1. On the left side we have 0 equals 9x minus 4. You add 4 to both sides, and then you divide by 9. So x equals 9 over 4. 56, replace the f of x with 0, and then 3 over 7. So we're left with this, and we want to solve for x. So first thing I'm going to do is multiply both sides by 7. So the 7 over 7 reduces to 1, so it's gone. And 7 times 0 is 0, so this gives you 2x minus 3, minus right there. I'm going to add 3 to both sides, so that's going to give me 3 equals 2x, and then we divide by 2 on both sides, so we end up with x equals 3 over 2. And that's it for that one. For 57 through 66, we need to find the domain of each function. So 57 is a polynomial. And remember what I said in class, we start off with assuming that the domain is all reals, and then we look to see if the function itself has any of the restrictions that we mentioned. So it's going to be x in the denominator or x inside a square root. Neither one of those is here. We don't have that. So then for this we say domain is all reals. Number 58 is another polynomial, and the domain of all polynomials is all real numbers. So the domain here, all real numbers. So domain, all reals. 59 is a rational function. We have t in the denominator, so we know that this function, the value for t could be any number except for 0. Because if t equals 0, t such that t cannot equal 0. Because if t were 0, then this function would be undefined. Okay, 60 is a rational function. So we look at the denominator, and we have to make sure that the denominator does not equal 0. So the only number that makes the denominator 0 is negative 5. Y is negative 5. So then we say for domain, it's all y such that y cannot equal negative 5. Again, because if y were equal to negative 5, then we would have an undefined function. So here it is. Number 61 is a cubed root function. And again, I mentioned something like this in class where, cube roots, or actually any odd numbered roots, don't have any restrictions on the variable. because you could have negative numbers inside that radical if it's a cubed root or an odd number, odd index root, rather. So this one, domain, is all real numbers. Okay, so 62 is another radical function. The index here is an even number, 4. So we're looking at the fourth root of x squared plus 3x. So with this problem or this function, we have to be careful about what goes inside the radical. We have to ensure that it's greater than or equal to 0. So I'm going to say x squared plus 3x has to be greater than or equal to 0. So one thing we could do with this quadratic is factor. I can factor out an x. Again, remember it's greater than or equal to 0. Now remember what this means. This means that one number times another number is greater than or equal to 0. Okay, so what this tells me that it has to be a positive 0 or a positive number, right? If it has to be greater than 0. So remember, in order to get a positive result after multiplying two numbers, either they're both positive, whoops, gotta change the pen, they're both positive, two positives, or they're both negative, right? Both of these give me a positive result. Okay, two positives or two negatives. So we need to find the zeros for each of the factors. So the 0 for the first factor for this one is 0. And the 0 for this factor is -3. So I'm going to place them on a number line. Change the pen. I'm going to place the two zeros on a number line. So this is -3 and this is 0. I'll place the first factor down here and then the other one right here. So for x, I know that the 0 for that one is 0. Sorry, so I'm going to put a 0 here. Any number greater than 0 is going to give me a positive result. Any number less than 0 is going to give me a negative result for the x, for this one right here. Okay, now I'm going to move on to x plus 3. The 0 for x plus 3 is -3, so that's the 0 for that factor. Any number bigger than -3 is going to give me a positive result, and any number less than -3 is going to give me a negative result. Okay, so I have a little sign chart or a little sign graph here. Now remember what the problem is. It's saying this number times this number has to be greater than or equal to 0. So when I look over here, a negative, let me change the color, a negative times a negative is going to give me a positive. A positive times a negative is going to give me a negative. And a positive times a positive is going to give me a positive. And I'm looking for all products greater than or equal to 0. So that means that my answer has to be from here to here and from here to here, because that's where I have my positives, my positive results. So how you write the answer, you could say all x such that x is less than or equal to -3, or x is greater than or equal to 0. And that would be the domain for this problem. In interval notation, you would write from -infinity to -3, bracket, parentheses on the negative infinity, union with 0 to positive infinity, bracket on the 0, parentheses on the infinity. So that's an interval notation that's saying the same exact thing. Okay, for number 63, we have g of x, and again, you notice we have x's in the denominators. So we just have to ensure that those denominators are not 0. So for the first part of the function, that 1 over x, we know that x such that x cannot be 0. And then for the second part right here, we know that we look at the denominator and we just say that x cannot be negative 2. So you can just combine them like this in the same braces, and there's your answer. Okay, for number 64, we want to find the domain of h of x. Again, notice that we have x in the denominator, so we have to ensure that that denominator is not equal to 0. We have a quadratic, right, x squared minus 2x, so what I'm going to do is I'm going to factor the denominator, so I can factor out an x, which leaves me with x times the quantity of x minus 2. And then you set each factor equal to 0, so this one gives me x equals 0, and this one gives me x equals 2. Those are the two values that would make the denominator 0. So for the domain, you would say all x such that x cannot be 0 or 2. And then your braces, and you're done. Okay, for number 65, you have y, the square root of y minus 10 in the denominator. So you have to make sure, first off, that the denominator does not equal 0, and secondly, that this number in here is greater than 0. Okay? Normally, you would say greater than or equal to 0, but because it's in the denominator, we just have to make sure that it's greater than, that this here is greater than 0. So what makes this denominator 0 is 10. So for our domain, we want all values of y such that y is greater than 10, not equal to, but greater than. And so that's how you write it with set builder notation. If you want to write it in interval notation, you would say 10 to infinity, parentheses on each end, okay, because it cannot be 10, so that's why we're not using the brackets. Okay, for number 66, we have both, two things that we have to watch for. First off, we have an x in the denominator, and then we have in the numerator, we have this radical, square root. So I need to make sure that the denominator does not equal 0, and at the same time, make sure that this x plus 6 is greater than or equal to 0. Okay? So what makes the numerator, what makes the numerator 0? The negative 6, right? Negative 6 plus 6 is 0. So I can, I know that negative 6, I have to choose numbers greater than or equal to negative 6 up here. The problem is I cannot use negative 6 in the denominator, right? So then my domain is all values x such that x is greater than negative 6, not equal to. And why again? Because if I had a negative 6, that would make the denominator 0. That's the reason why. If this wasn't there, then I would include the equal to. And then to write this in interval notation, we would say from negative 6 to infinity, again parentheses on both ends because we cannot use negative 6 in our domain. Okay, for number 67 through 70, they ask you to use a graphing calculator to graph the functions. You may use Desmos.com, or if you have a handheld calculator, go ahead and use that one.